In this video, we're going to explore how Python uses operator precedence. That is, how does Python choose which operator to evaluate first, the multiplication or the addition? Let's run it and see. We get 13. The 5 times 2 was executed first, giving a result of 10, and then we added the 3 and the 10 to get 13. The important thing to remember is that Python assigns operators precedence in the exact same way as the conventional math rules do. In the above expression, multiplication always has higher precedence than addition, and so we could write this expression as 3 plus 5 times 2 to show that the 5 times 2 is executed first. And note that adding brackets really does change the order of operations. So if I put brackets around the 3 plus 5, I would expect to get 16. Because now Python evaluates the 3 plus 5 first, giving us 8, and then multiplies that with 2. Now let's look at a more complicated expression. Following the basic arithmetic rules of order of operations, we know that exponentiation, or the 2 star star 2, is the first thing that gets evaluated. Notice that this dash is really a negative sign, and so I know that this last number is negative 2. We also know that division comes before addition, but then we have to ask ourselves, which division comes first? This one or this one? And again, we get our answer from math. When we have two of the same operators, we always evaluate them left to right. So in this case, first 8 would be divided by 2 to the power of 2, and then the result of that would be divided by negative 2. And then finally, 4 would be added to the result. Let's try to figure out what this evaluates to without hitting enter, just so we know that we're clear on what we're doing. First thing we do is evaluate 2 to the power of 2. That gives us 4. Next, we evaluate 8 divided by 4, which gives us 2. Next, we evaluate 2 divided by negative 2, which gives us negative 1. And finally, we evaluate 4 plus negative 1, which gives us 3. This answer over here might surprise you a little. The result is a float, not an int. And that's because we use division. Every time that Python uses division, the result is a float. And so this whole thing, even though we know it evaluates to negative 1, Python stores it as negative 1.0. And when we add an int to a float, Python returns a float. And that's why we get 3.0. Awesome.